recommend you follow me. If you do, I'm sorry. But you may see some interesting tweets from me working on my demos last night. So if you want a spoiler, you can go check that out. As it was said, I work at this program, this interesting company called NPM, which doesn't stand for Node Package Manager, but that's what it does. Does anybody here know what Node.js is? Okay, cool, yeah, all right. So, how many people have NPM installed something today? Nice. Okay, cool. But yeah, so this is one of my jobs, and we work with the Node runtime, and I am the individual membership representative on the board of directors. And if you've ever been interested in open source governance, come talk to me later. It's a fascinating thing, and it's extremely messy. We're actually still figuring out what an individual membership director does, so that's a fun thing. But in general, I like programming in JavaScript. If you have a problem with JavaScript, come fight me about it. I have no problem with that. But I started out writing Ruby, and kind of along the way I also learned Erlang, which is a super fascinating language. In general, I just really, really love programming languages. And part of the reason I like programming languages is because I really like thinking about thinking. And in particular, I like the type of thinking that happens when people write code. And so keep that in mind, I guess, as I go through my topics. This is the frame of reference that I use whenever I'm approaching anything in computer science. So we're going to talk about Intermesos, and Intermesos is an interesting project. The goal of Intermesos is to be a teaching operating system that is specifically focused on introducing systems programming concepts to pretty much anybody who's already done some level of development. So basically the idea is, do you know some JavaScript? Cool, let's build an operating system, right? And now you might be thinking, oh wow, that sounds pretty bold, right? But this is actually part of kind of how I even got into this project in the first place. So one night, my partner and I were just kind of hanging out, and he was like, yo, do you want to like just stay in tonight, put on some comfy pants, and do this neat kernel tutorial? And it was like, oh yeah. I definitely want to do that. That sounds friggin' awesome. Like immediately I was like, this is going to be super cool. And then something started to sink in. All right? I was like, yeah, I'm going to get close to the metal. This is going to be cool. But can I write an operating system? Like, how the heck do you even start thinking about doing that? Like, uh-oh. Now I'm like, maybe this is not going to be fun at all, right? Like, I don't even know if I can, but I probably definitely should not, right? I should not write an operating system. I like writing JavaScript, right? I'm not supposed to be doing this kind of systems programming stuff. All right, I just started getting super anxious, and I wanted to put it off. All right, I was like, no, you know, maybe I could just literally do anything else besides write an operating system. And it turns out that I'm not the only person who, when they think about writing an operating system, gets a little bit anxious, gets a little impostery about whether or not I should do it. And it has a lot to do with the attitudes that are perfectly exemplified by this fascinating piece of internet called osdev.org. Has anybody gone to osdev.org before? All right, so good. Maybe some of you have not been ruined yet. So I'm going to give you some choice passages from this page. All right, and I've been told that most of the people who have written content on this page are 14-year-old boys, and the reason I know that is because people who are 14-year-old boys who wrote on this page told me that. So here's some interesting stuff, but what I want to start with saying is that I think that this is garbage, total garbage. So this is the required knowledge page. So it starts by saying you need to know basic computer science, and they define basic computer science as being intimately familiar with hexadecimal and binary notation. How many people here are intimately familiar with hexadecimal and binary notation? I was like, there's usually one who's like, yeah, it's definitely me. All right, so that's cool, but I'm not sure I'd call that basic computer science. Well, again, we'll fight in the parking lot or something. That's fine. But yeah, that's ridiculous. All right, and then it says programming experience. Learning about programming with an open source project is considered a bad idea. Now, you'd think by now that the whole like considered harmful meme would have like run its course, but it has not. And I completely think that this is ridiculous. I think there's a lot of really amazing things that you can learn about programming by actually building an operating system. So we're going to say, no, that's also a big deal. No good. And then they end it with this. Failure to comply will make you look silly. Now this is why I'm thinking maybe 14-year-old boy, because silly is the worst thing you're going to tell me I'm going to look like. Also, failure to comply. Oh my goodness, there's compliance engineers running around being like, don't write an operating system. All right, so yeah, that is completely ridiculous. And so the tutorial that we're going to work at, I finally was like, okay, it's going to be cool. And it turns out that not everybody who writes operating systems or operating systems tutorials thinks that you have to be some sort of computer to write an operating system, basically. And so we started out with this tutorial by this person named Philip Opperman called Writing an Operating System in Rust. And so before I dive into the operating system stuff, there's one thing in here that maybe people don't know about, which is Rust. How many people here know of Rust beyond like that stuff that grows on metal? All right. So fun fact, if you are interested in Rust, I was going to say there are some people who do core stuff in the back there, and they love to get you into it. I do not work on core in Rust. I just work like nearby the people who do. So to talk a little bit about Rust, it's like, what's Rust? So this is Rust logo. Rust has a much cuter logo that is actually a little crab. So people who write Rust are called Rustaceans. And so there's a small crab named Ferris, and so if you're into chemistry jokes, there you go. But Rust is a really interesting language. Rust describes itself like this. It says, Rust is a systems programming language that runs blazingly fast, prevents seg faults, and guarantees thread safety. And so when I first read this, I was like, what? I don't know what that is. And so I don't know, potentially that is something that would sell to you, but I feel like that doesn't sell to a lot of people. And so the way I like to talk about Rust, all right, is to talk about the fact that computers, how do they work? They don't. All right, and it turns out that a lot of the stuff that we write on computers is written in languages that kind of make it a little bit hard to do things right. So computers are kind of like this, right? Sometimes your program just doesn't quite hit the mark. And that can be because you might be writing in something called C++. How many people here have written C++? How many people knew they had this cool new logo for it? I had no idea. I saw this last night and I was like, interesting. It looks like a node module. Anyways, I was like, okay, C++. Now, C++ notoriously gives you what is called a foot gun. How many people here know what a foot gun is? How many people can imagine what it is? All right. It's not a gun you use on your feet. It's something that you shoot yourself in the foot with. And so a lot of times when you think about programming languages like C or C++, they kind of end up having you do something like this. They don't prevent a situation like that, which you would like it to, right? This is kind of brutal. And so one of the goals with Rust, all right, and it was like reacting to these ideas, C also has the same problem, kind of, you're trying, you're really trying, but your tool is not helping you. Yeah, this one's awesome, right? It's good. All right, so how many people are aware of this situation? All right, so TLDR, somebody wrote something in C that leaked a lot of stuff all over the internet. Is pretty much what we can understand. And now, the thing here is that their tool, the C programming language, didn't help stop that. Now, no tool is perfect, and no tool can always make you safe, all right? But the idea of Rust is that it's going to try and help you. So with this cloud bleed thing, they misused a library, and the internet lost its mind, partially because all of the internet spilled out onto all of the internet. This is a fascinating bug if you want to read about it more. But the way I like to define Rust is that Rust is a programming language that gives you the power of a language like C++ or C. But its main goal is to actively try to keep you from failing by having a compiler that enforces safety. Now, I almost grabbed a slide from a presenter who is going to present later, who talks about the compiler in Rust kind of being a referee to keep you safe. And so I don't know if that's coming up in your talk, but it's super awesome. It's Liz. But yeah, in the end, the goal of Rust, all right, is not to be like, you have to be a wizard to do this, all right? Rust wants you to succeed. It is designed with empowering you in mind. It is not there to be like, you're not smart enough to use me. It's literally just there trying to help you to be able to write systems programming. And a lot of the times, unfortunately, the tools around systems programming are not really doing that. So it's kind of unique in this way. And Rust was a perfect programming language to write this operating system in, because fundamentally, the goal of this operating system is the same as Rust. The idea is that it wants to empower you to be successful and learn. All right, so we'll talk a bit more about that. So the title of my talk is I Can Operating System and So Can You. But before I continue, how many people have operating systems? Have you written or tried to edit an operating system before? That's super awesome. I should mention, I know there's a lot of people here who are in computer science programs. I never took a single computer science class in college. I did hear that a lot of people took operating systems classes in college, but never had any idea what was going on the entire time. Maybe they were lying to me, maybe they weren't. I have no idea because I've never taken one. But that being said, even if you are not a computer science student, I think that you can write operating systems and have a super fun time. Alright, so this project that evening when I stayed in, I ended up writing this, which was like my crowning achievement, which was this tiny, tiny operating system that I wrote in Rust. Now, I tweeted this out, it was very popular, but fundamentally this kind of gives you the question like, okay, but like, you're calling this an operating system? Okay, what is an operating system, right? What is that at all? How many people here think they could define operating system right now? This is where we start. For what it's worth, this is also where we end, but it's going to take 20 more minutes to get there. So yeah, what is an operating system? Literally, who knows? And it turns out that a lot of the people who write about operating systems also are not really sure. So from the Modern Operating Systems book, it says, it's hard to pin down what an operating system is, other than saying it is software that runs in kernel mode. So that's basically like the definition of a monad too. It doesn't make any sense. And then even that is not always true. Part of the problem is that operating systems perform two basically unrelated functions: providing application programmers a clean, abstract set of resources instead of the messy hardware ones, and then also managing these hardware resources. So fundamentally, if you read this, honestly, it's like, what is an operating system? We don't really have an answer still. All right, so from this book, 3 Easy Pieces, they also say there's 3 definitions: virtualization, concurrency, and persistence. Done. Hold on, not quite. They make it sound simple, but then they say, based on these 3 definitions, software that securely multiplexes and abstracts physical resources. But then again, they follow up. We believe that this definition, specifically its view of the operating system as an abstractor of hardware, is crippling and wrong. Okay. So far the literature has been extremely helpful on this topic, right? So fundamentally, when I try and talk about an operating system, I like to talk about what it does. And so I like to say an operating system is a program that provides a platform for other programs. So it's a program supporting other programs. And it gives it basically 2 things. It gives it abstractions and isolation. So I'm trying to get rid of being crippling and wrong by adding isolation in there, since they don't like the abstractions thing. And so abstractions are a really fun topic, and they're probably my absolute favorite thing to talk about in computer science at all. Fundamentally, I would probably argue with you that abstractions are the only thing we're doing in computer science, but that's probably for the conference session later. But many of the common abstractions that an operating system are going to give you are things like address spaces, memory protection, kind of input-output stuff, files, and they kind of all follow this same pattern. So fundamentally, let's say I go to write a program, and I want to write a program for a piece of hardware. So let's say I want to write a program for my phone. So I write a program, and I write it for hardware A, and that's super awesome, right? But then I want to write it for hardware B. So say maybe another iPhone. All right? In order to do that, I need to throw an abstraction in the middle, because my program, when it was written for program A, or for hardware A, was directly coupled to that hardware's requirements. And then, so in order to get hardware B, I throw this kind of buffer in the middle, and that's what the operating system is. It's going to allow me to be able to write for multiple hardwares. Now, you might be familiar with this type of pattern because it continues. So let's say I want to write something for more than one operating system. This is where the idea of a virtual machine comes in. So the Java virtual machine, for example. So if I want to write for multiple operating systems, I throw that abstraction of a virtual machine in the middle. And so what we can see here is that when we want to diversify the things that we're able to support, we throw an abstracting layer in the middle to be allowed to be able to do that type of work, to diversify the things that we can point to. And so this pattern of abstraction has a pretty simple pattern, which is I have A is written explicitly for X, but if I want to support X and Y, I need to throw abstraction B in the middle. And you can find this pattern of abstraction all over computer science. But for our purposes, we're thinking about it in the operating system level. All right, so that's abstraction. The next thing is isolation. And this is a famous mathematician. His name is George E. Box. And I think he said one of the most profound things anyone has ever said. And that is, remember that all models, or abstractions, are wrong. Every single one is wrong. The practical question is, how wrong do they have to be to not be useful? So one of my favorite things about operating systems, and it's something that my partner who I worked on this with likes to say, is an operating system's job is to lie. All right, so as an abstractor and an isolator, this operating system is actually just totally lying. And so when we talk about isolation, one of the things that the operating system does is it makes your program believe it is the only program running. Now we all know that, I mean, look at all the computers in here. How many of these computers are running one program? All those programs think that they're running, wait, oh yeah? But yeah, all those programs think that they're running on their own, individually. And it's the operating system that's being allowed to, that's letting you do this. And so we kind of come to this question that we often get when we're talking about the Intermezos project, is why the heck did you name it this super weird thing, Intermezzo? Now the complicated answer is, do you know who Deleuze and Guattari are? And so if there's any philosophy majors in here, we can talk about that later. But the simpler answer is that intermezzo is a musical term that talks about basically a musical piece that goes in between things. And so with this understanding of abstraction and it being key to operating systems, we wanted to name the operating system something that kind of reflects that abstraction part, so going in the middle. And so the intermezzos, the operating system, is about something that goes in the middle. Alright, so we've been talking about what is operating system, and we saw in a lot of the definitions it refers to the thing kernel. Now the first thing I'll say is, the first times I gave this talk, I spelled kernel wrong. I used an A at the end instead of an E, and it turns out that that's about corn and not about computers. But it turns out that also this term is pretty complicated. So this is kind of fuzzy. And remember that previous definition said it's the software that runs in kernel mode. But also that's not even true. So my best working definition for what a kernel is that it's kind of the core of the operating system. Now this is totally up for debate. People like talking about this a lot. In fact, kernels and all the different types of them was like a really hot topic, like I think around like a year ago. There's all these like explosion of different types of kernels: monolithic kernel, microkernel, exokernel. There's like tons and tons of different types of kernels. I don't even know, all right? But neither do these people, right? It's like, okay, I don't know. And fundamentally, I hope overwhelmingly what you're realizing is that this thing where everyone was like, you have to be super smart to do operating systems, but also we have no idea what they are. No one has the terms for it. That makes it very difficult. All right, so a lot of people are like, okay, intermezzo is an operating system. What kind of operating system is it? And I'm like, it doesn't matter. All right, you can't even define what they are in the first place. But fundamentally, the goal of intermezzos is to learn how to build an operating system. And so we could spend a whole bunch of time trying to design the perfect operating system, but then we'd probably never actually build it. And so one of the main design principles of intermezzos is that we want to build something. Let's hit the keys, right? Let's spend all this time in theory space, because the goal is to learn. Definitely not to make the best operating system that ever existed, assuming that that would ever be possible. All right, so what is operating system? I kind of like to define it like this, which is, if you wish to computer from scratch, you must first invent the universe, or invent an operating system, right? Now, I don't know if I'm like too much of an oldie, but that is actually a quote from this gentleman whose name is Carl Sagan, who is like the older, much better version of Neil deGrasse Tyson, who we saw earlier. Throw a little shade there. But he wrote something that said, if you wish to make an apple pie from scratch, you must first invent the universe. And I want to caution you here, because a lot of times people will tell other people that they are not real programmers if they are not close to the metal. And so I want to say, you don't actually have to invent the universe to like be a programmer. But if you want to, you can, and like you kind of should, because it's super fun, as Carl Sagan says. You're awesome. All right. Like the reason I like it is it's like I'm gonna make the computer do a thing like kind of from scratch with like basically nothing else. This is Lil Jon, and he sings a song called Get Low, and I'm like, yeah, get low, level programming. I'm so sorry. I was told that joke would be too old for people too. Whatever, I did it anyways. All right, so with that being said, I've been talking a lot about this Intermesos project. Let's kind of talk about the nitty-gritty work of it. All right, so the prerequisites for this are trying to get up and running. We're going to talk about some Linux dependencies, and I'll show you some utilities. Now, the most fascinating thing about operating systems to me was that I know that getting started and getting a dev environment set up, literally for anything, is pretty complicated. And for operating systems, I didn't even know like how you would start. This is a colleague of mine who tweeted, I wonder how many programmers went their entire career without ever getting their development environment working. This is too honest. If I spend a lot of time teaching beginners, and like the first 48 hours are like, let's get your computer so that it can get this working. And so one of the things that I found is once I was able to actually get an environment up and running to like actually be able to start writing an operating system, everything felt a lot more concrete. All right, so like yeah, I don't even know how. So we have several dependencies in here, all of which are kind of difficult to pronounce. So the first one is this thing called NASM, which is an assembler, which is going to take assembly language and turn it into binary. Fundamentally, binary is what's going to run everything. You have a LD, which is a linker, which is going to make binary out of certain files and stick them together. We have this thing called grub. A lot of these things have names that I like imagine little creatures. Grub is going to take this stuff and make a bootable ISO, which is like a fancy word for like that thing that used to come on CD-ROMs, you know. And then this one's really fun. So it's, I think you're supposed to say XOR ISO, but I pronounce it chorizo. And I'm certain that is 100% correct. Please confirm. And then finally, there's a really fun thing called Keynote, which is basically going to be your emulator virtualizer. This is the thing that made it click for me. Like, if you've ever done any sort of development, like maybe for an iPhone, you're using, there's a virtualizer for like doing stuff on iOS. Kibu is basically a virtualizer for making operating system stuff. And so we're going to see a bunch of that later. All right. Then there's a couple of utilities that are really awesome. Something that's really hard about operating system development is that you get really bad errors, and it's hard to like look into things. And so these are two things, hex dump and obj dump, dumps tools. They're going to let you be able to like look into your files and actually kind of understand that they've been compiled correctly. All right. And so when you're running an operating system, one of the first questions you're going to have to ask yourself is, what happens when you turn on your computer? Because when you turn on your computer, that's when the operating system's got to start doing some stuff. It's the work to be done. So the first step that happens is your hardware is going to load BIOS, which I had no idea stood for Basic Input-Output Service, which is pretty neat. And then BIOS loads grub, which is not a cute worm, but the grand unified bootloader. And then finally, grub is going to load our kernel. In this process, we're going to have to take a couple of our files and stick them together. And this is called linking. And you're able to tell how the sections in the input file should be mapped out into the output file. Basically, like what should go first. It kind of controls this memory layout. Fundamentally, the important part here is you have to make sure your header info is at the top. That's really it. It can sound very complicated, but that's really the most important part. And then what comes next? What comes next is something that's incredibly fascinating, and I was talking to a couple of people right before this talk, but it turns out that all that browser incompatibility that you find so frustrating It's hidden from a lot of us, but down below there's also a lot of super weird incompatibility. And one of the things, because of hardware incompatibility, that every computer does when it starts up, I guess not every computer, but most computers, is it has to do something called jump into long mode, which is to say your computer thinks it's a 32-bit computer until magically it doesn't. And fundamentally it really is kind of magic, where it's been said it's very endearing that my computer is willing to jump off a cliff for me every time it turns on. So fundamentally your computer just thinks that it's this one thing, and then you're like, no, but actually, and it's like, sure. And then luckily it has the hardware to pull it off. But that's super fun. Now, the types of programming that you have to do to get your computer to do this is actually not that hard, but it's extremely tedious. Because in the end, assembly language is kind of beautiful in that it only has very few abstractions. There's not many things that you can do. There's not a lot of like standard library to learn in assembly. It's all pretty basic, like move this, copy this. And so fundamentally you just have to write out moving all of these things around. It's just like a giant shift. So it's not complicated, it's kind of boring. Or fun, depending if you like that stuff. So we've been talking a little abstractly about intermezzo, so let's take a look at how it works. Who wants to see some code, right? Alright. I don't know what I was searching for with Bert there. Super weird. Can't answer it. No answers there. Alrighty. Alright, so by the way, these demos are available. These slides, these demos, and the entire project are all open source and very openly licensed, so you can play with them later. Alright, so I got 3 demos for you. The very first one is what is called bare bones. So a bare bones part of an operating system project tends to be like, just get it booting, and then do nothing else. So I will say that I have done one extra thing beyond just booting it up, and this is kind of my favorite part of doing the operating system right now, is I kind of use it as like a glitchy MS Paint style word processor, and I'll show you what I mean by that. So first let's just boot it up and see what happens. So I'm going to write in make run, it's going to pop that up, and here we go. This is the operating system. You can see it says, hello, Con, yay! Now this is not the absolutely super fun part. Let me show you under the hood how complicated this word processor of mine is. So it looks like this. And so we can, oh, what is this? Oh, that's another project. And this is not big enough. I really wish iTerm didn't make the window larger when I make the text larger. Okay. Alright, so if we go into bare bones, so this is written in Rust, but it's actually using a little bit of assembly as well. We think that we'll be able to get the assembly potentially all the way out of it, which would be super cool. So in a Rust project, this is kind of, did someone say something? No? Okay. There's ghosts. Alright, so in a Rust project, this is a quick thing that you'll see here. You're going to have a source file, a source directory, and inside that source directory is where our files are, and I'm going to go into main.rs. Alright, so yes, I do use Vim with no syntax highlighting, and I'm totally fine with it. So what you can see here is we boot up, and then we're going to run this kmain function. And what I've done is in ASCII hex, I have written out all of these words. Now, does anybody know why I didn't write hello all as one word? I know you know, Jake. I'll show you in a quick second because it's the absolute favorite part of the operating system for me. So basically what I've done here is I'm able to encode the letters on the screen. I can pop this up right next to it, actually. Kimu, where are you? You are. All right, so each one of these variables kind of maps to one of these things. So we have hello, con. And so the hell plus the O is this lines 1 through 5 here. Now, how this is working in the encoding is that the first, they're 4-character long bits that represent a letter. And so the first two is a background color, a foreground color, and then the 2-character ASCII hex code for that character. And then additionally, because of endianness, I think it's written backwards, but I guess it's forwards depending on endianness. Also, the weird thing about, how many people here know what endianness is? All right. It has to do with what order you read the characters in, basically, and it has to, I've heard that the lore is that it started with how you're supposed to eat an egg from like the small side or the big side. I don't eat eggs, so I don't get it. But yeah, so that's how we're coding that in. Now, a fun thing with this that I super love is I can make this glitch out pretty hard. So I'm just going to add some random characters here at the end of these. Does anyone have any idea what they think will happen with me adding these weird characters at the end? Any thoughts?
Kernel panic.
All right, so maybe it'll panic. What else do we think might happen? Any guesses? All right, we're going to close this out. We'll run this again. So the first thing you saw is Rust was like, hey, you're kind of messing up here. All right, we're out of range. All right, we've got an overflow. The overflow makes it make happy faces. There are cool reasons why, but I leave those as an exercise for the viewer to figure out why. When I cause an overflow, I can make all the characters turn into happy faces. That being said, this is like the most complicated way to get a computer to error out an emoji, and I'm extremely proud of it. All right, so this is the bare bones kernel with me just kind of playing around like it's an like some sort of MS Paint situation, but oh, that's not how you do that. Clear. All right, so now let's actually take a look at the actual kernel and how it works. Oh, come on. All right. So now let's hop into the kernel. Oh. All right. So we have a similar thing. This is also written in Rust. And so we're also going to be running that file that's in source, just to give you a little look at what it looks like. All right. One of the amazing things about being able to write an operating system in Rust is that I'm able to use packages and package management. It's a really, really nice, I mean, obviously I work at NPM, so I have a soft spot for package management, for sure. But being able to use other bits of code and like reliably pull them in is something that you don't see a lot as you move down the stack with tools. And so it's extremely convenient there. So again, you see we have this kmain, just like we had last time. You can see that there's a lot less of that garbage with all the bits and the numbers, which is super irritating. That's obviously not a reliable way to be writing any software. It's extremely brittle, as I showed you with the happy faces. But fundamentally, this is going to be loading up some stuff. And so currently, right now, the state of the operating system is that we have a VGA implementation, which I'll show you in a second. But it accepts keyboard input. And so let's take a look at what that looks like. So I can say make run, and it pops up Keynote. So here we are, we have Keynote, and I can type letters. Hello, hello, hello. Now some characters don't work, so that was supposed to be a happy face. It's still not a happy face because we're not necessarily seeing the shift keys or the enter keys. That being said, if you're interested in contributing, this is ready just for you to plug in something that maybe knows what a shift key is to add to it. Now, fascinatingly enough, oh, that was a terrible letter to be repeating. What am I doing? Just kidding. See that right there? The fact that it went down to the next line? Believe it or not, that's really hard. Getting it to do that was extremely difficult, and I'm going to show you some of the glitch that happened when I did all the math wrong. Oh, this is going to take forever, so I won't do it. Why aren't you working? Yeah. It also, if you go all the way down to the bottom of the screen, will scroll up. Turns out that that's also like a pretty difficult task, but it was super fun to solve, and I'm not good at math, so I had to draw it all out and got the math wrong like 5 or 6 times, but that was super fun. All right. Let's quit. Now, all of that was made possible because of this thing that we made called our VGA driver. Now, in a very unusual way, we wrote the entire VGA driver in Rust, and we also test drove it. So in writing systems, like in doing systems programming, it's very hard. You get like a lot of really kind of terrible errors. It's hard to introspect. But because we were able to write it in Rust, we were able to take it out as its own separate package, write suites of tests, and then write the code to pass it, and then take that and just drop it into our operating system, which made doing this all extremely, like, it's much easier, much simpler, but very nice to isolate just a certain thing out. And so to show you what that looks like, let's clear this. Whoa, I get tight. I'm nervous. It happens. All right, so we can go into VGA. All right, so you can see here, this is purely in Rust now. And so quickly, just to point out a couple of the Rust things, cargo toml is where we list all of our dependencies. So if we want to pull in other Rust stuff, cargo lock locks down those dependencies for us. The source is where all of our source files are. Target is where all the compiled stuff goes. And then tests is where we wrote our tests to be able to write this. And so if we go into source, unlike last time, we were able to, we wrote this as a lib.rs because this is actually a library that the operating system uses. So we're taking the components of the operating system and actually able to packagize them, which is super neat. So to run tests, you can just run cargo test. And like any good demoer, I have both pre-baked the solution and also pre-baked a problem here. So you can see we have several tests. So the things that our VGA driver had to do, if you think about breaking it down, is it has to be able to write a letter, write a word, write multiple words, write a new line, that's for the scrolling, and then also scroll. And then we also abstracted out those color codes, because how many people are going to memorize all of the colors and all the different backgrounds and foregrounds you're able to have? You'd be surprised that it's like, they actually have more than like the 5 basic colors. It's interesting, the ones that they've chosen. But that's pretty neat, and we abstracted all that out. Now, in the end, there's one bit of this that did not work. And so what I can do is I can pull up our code, we're already in source, and take a look at it. So here's where you can start seeing some of where that math shenanigans came up, where I'm hard coding in here the rows and the columns in my display. Why are these numbers the way they are? Because those were the numbers that were chosen long ago and they just don't change, and those are the ones that you know that they're supposed to be. Which is sadly the answer to lots of questions why in computer science. It's like, this is how we always did it forever, and so this is what you do. And so as you can look through here, fundamentally, the VGA driver is really interesting, and you can, without really knowing even all that much, kind of get an idea for it. How many people here know what an array is? All right. Then have you ever had an array of arrays? Matrix, maybe. All right. That's all the VGA driver really does, is manipulate this array of arrays. And so basically, you're taking those 4-letter codes and you're sticking them into an item in the array, and then having a line for each one of those. And that's fundamentally all that we're doing. So again, there's nothing fancy about this. There's nothing complicated. It's just kind of tediously putting things into and out of arrays. So fundamentally, the way this works is it has an idea of what the VGA matrix should look like, and then it fills in a buffer. And then at the very end, it takes that buffer and everything that's inside of it, and it pushes it out onto that slice or array that the VGA understands. And so the thing that I have not implemented here, if we go back and look at our tests, is we don't have this method called flush implemented. It failed. And so we can just go in here. I didn't memorize what line it's on. Here we go. So right now in our flush method, I just have it panicking. And so in the end, what we need to do is we just need to take that slice, or the buffer, and clone it right onto the slice. So I'm just going to uncomment this, get rid of that. And in doing that, then I can say cargo test, and we can see that all the tests pass. Now, fundamentally, the fact, oh, I'm taking too long. All right. the cool thing here is not necessarily the code. The cool thing here is that Rust as a tool is allowing us to take software practices that make our lives easier in all different other types of programming and apply them to something that doesn't really have the tooling to make it easy, like systems programming or developing an operating system. I can feel a lot more confident writing out what I think behavior should be in a package than writing the little methods and then dropping it in an operating system. And I think that that's really empowering. All right, so to finish this all up. All right, so there's this cartoon that I really love by this guy named Guiden. He's French. And he says, writing is nature's way of letting you know how sloppy your thinking is. And I like taking this and making it my own by saying, teaching is nature's way of letting you know how sloppy your thinking is. So how many people in here are teachers? Not enough. All right, the absolute best way to know, like, to get really good at programming or really to get good at anything is to try and teach someone, because you will find those holes immediately. All right, so my challenge to you here is go write some irresponsible code, really irresponsible. Again, it doesn't have to be the best thing. In fact, write something that's terrible and glitched out. All right, and then go teach somebody else to do the same thing. All right, so this is what happened when I got the math wrong on the scroller. This is super cool. This is fun. I honestly think that this is more interesting than when it actually worked. I thought that this was super neat. Again, Liz, a lot of people have tried out this project and they have been super enjoying it. Particularly people who thought that maybe operating systems weren't for them, but maybe with this type of attitude, they could be. So we've been teaching some tutorials in person with this curriculum, and it's been super duper fun. And so if you're interested in that, you should check out the curriculum. You could use it to teach your own thing if you wanted. We ran that at Rust Belt Rust, which was a conference in Pittsburgh, Pennsylvania in the United States, and it was pretty awesome. All right, and as you can see, I actually didn't discover the happy face bug, a student did, and I thought that that was pretty awesome. They were like, that face when your code doesn't work, but everyone's happy anyway. All right, so please contribute to this project, all right? We have tons of contributors and we're looking for more. And you don't have to contribute code to contribute to it. In fact, we have the book, which is the curriculum that follows up with this, with the kernel. And we've had tons of contributors on that, and that's always useful. In fact, if you're a beginner, you're probably a better contributor because you can go in and say, this stuff doesn't make any sense. And that's a super valid contribution. All right, we want you to contribute, and it doesn't matter who you are. Don't worry about any required knowledge. If you don't know hexadecimal, all the power to you, all right? And if anyone says that you shouldn't be writing an operating system, all right, that's garbage, all right? Failure to comply will make you look silly, and that's a super good thing. And so I will leave you with this. It's a Bertrand Russell quote, and I really dig him. Actually, I don't really dig him, but I really dig this quote. I almost failed out of a philosophy class because I hated Frege so much that I wrote like a whole diatribe about it. But he and I agree on this, and it says, as the above hasty survey must have made evident, my hasty survey as well, there are innumerable unsolved problems in this subject, and much work needs to be done. If any student is led into a serious study of mathematical logic, or operating systems, by this little book, it will have served the chief purpose for which it has been written. Personally, I think too long operating system has been gated to so many people, and there's so much work to be done on it that we need to have a bigger audience working on it. And so I hope that this talk has gotten you excited about operating systems, and so can you. Thank you.
Thanks, Ashley, for that very interesting kind of